Good morning, my dear students. Yes, yesterday we have discussed notice and three problems we have solved. Relation between A and B, how to find out lambda and some other example. Yes, today I am going to discuss another most important problem. So here is that. Let us discuss one by one how to find out for the solution. Here, look at the question. Discuss the continuity of the function f, where f is given as f of x, signal function 3 if conditions are 0, 1, 1, 3, 3, 10. So class interval 0 to 10 is there. In the between, class interval, keep in your mind. So we are going to define for the 0 less than x less than 10. It means 0 to 10. So here, so maximum numbers are right. So that intervals you have studied open interval, closed interval, semi-open, semi-closed in the first year. Same things, but here we are going to defining only two class intervals. Which those are? How to take the values? Let us discuss one by one. So here I am going to take a solution. Right? Given. So f of x is equal to signal function 3. Shall I write down here? Look at this one first. So observe, keen observation is most important. Think about this one. Alright? So when you are going to take 3, if right 0 less than x less than equal to 1 condition. So 4 if right so 1 less than x equal right. So just I am going to take here the class interval is there. This one shall I take? Already you have mentioned 0, no problem. Or otherwise, look at this question. So x is less than 1, x is equal to 1, right? So and another 1 less than x. When you can do that continuity, when you are going to take 0. That is another class of 3 different problems to solve. Try to understand. So then only I can take only at x. When you are going to take 0, that changes the class interval. So here another most important, right? One thing. So here 3 if 0 less than or equal to x, right? And 4 if so what is the value? 1 less than x. That is also possibilities. So look at this one, how you are going to express. So 0 less than x, right? So here another point, 0 is equal to x. So here, what is the value? 1 is less than x. Check it. So shall I write this one? What do you get called? LHS. No, it is not a LHS. Which one is LHS? And which one is the RHS? How you are going to take? So here 0 is very small and those are number increases. So 1 is small, both are increases. So here then only I cannot take this one 0, right? So I am going to take the values. So which one conditions? So x is less than or equal to 1. So 1 is less than x. Clear? So this class intervals. Then only I can split up both. X is less than 1. So here another one. X is equal to 1. So in this condition, 1 is less than x. So what about here? Look at these two conditions. When you are going to think about this one and think about this one. Clearly observe. So x is less than. Here 1 is big. Right? Others are very small. Look at it. 1 is only big. And others are 0, minus 1, minus 2, so on. So then only I can take this one. Right? Clear? How I am going to take the LHL? That is the most important. So look at this. 1 is very small. Here 1 is big, but here 1 is very small. Then in your pocket 2 rupees, 3 rupees, 4 rupees, so on. So then this is the positive side. Clear? I have finished my problems. Right? So while I am going to take 0, then only I can split up both. So it cannot consider properly. Then only I can go to define for the at x is equal to 1. So here at x is equal to 1. So where x is equal to 1, conditions are f of x is equal to 3, right? So already I have given statement yesterday, every constant function is, what you can call continuous. Right? Every constant function individually, you are individual person, you are a strong person, you are a continuous person. Individually, when you are going to take a single function, that is continuous because constant. Every constant function is continuous. Yesterday's notice. So next I am going to define. So whatever you can substitute, f of 1 is equal to 3. Finish? So because the only for the x does not change for the value because the reason constant. So next I am going to define LHL, limit x tends to 1 hyphen. So f of x, so what is the f of x means? Yeah, f of 3, that's over. So whatever you can apply, limit x tends to 1, so here 3, then got it? 3. So next one, RHL, limit x tends to 1 plus f of x, how I'm going to express each one, most important, limit x tends to 1, clear? Check it. So when you are going to define it, so 4 is there, right? This is 4. Every constant function is continuous. Hence, check it. LHL, RHL, otherwise you can state another one at f of x. So LHL is 3, RHL is 4. Both are not equal. Hence, f is not continuous, not coincide, not a continuous at x is equal to 1. This is the first condition. This is the first condition. First one. Next another one is, shall I go to f of x is equal to, so here check it. So if x, look at this one, x less than 3, this condition. So here that and another matching. In this one, 4 x is less than and 5 conditions split up. If so, here check it. I'm going to take this one only, not for the 10, right? So this is, what is the value? So 3 less than or equal to x, right? When you are going to take already these two I can define. So here 10 and 0 does not depend because the both are close interval, end between the point. So look at this one. Already I said that end between. So it means express from 0 to 10. In between the values are there, including and excluding, right? That is the first standard. Again, first here we are going to define for the class intervals. Let us look at this one again. So what we are going to define? So conditions already you know that. So directly I can take here less than. What about here? So x less than 3, right? Sorry, reverse I can write. So here what we are going to take? 3 less than x, right? So another one, 3 is equal to x, correct? When I am going to take a split of for the class n. Right now, you can think about these two. So look at this one. 3 is big. So other numbers are very small. So shall I take this one? L, H, L. What about this one? R, H, L. Obviously, x, look at this one. 3 is very small, others are big. So R, H, L, right? So easy to find out for the at x is equal to 3, right? So if, what is the value? F of x is equal to, conditions are 5. Already I said one statement, if every constant function individually continuous, every constant function is continuous, every rational function is continuous, every identity function is continuous, every trigonometry individually, some conditions are there in trigonometry only, so that all are the continuous function. So here f of 3, 5, right? So second one, So finish. LHL limit x tends to condition is 3. Hyper means left hand side. So this one f of x, right? Limit x tends to 3. Which function? So LHL. So shall I take 4, right? So whatever sums to 4. Clear. So next you are going to express for the values. Limit. Sorry, first I can write RHL limit x tends to 3 plus, it means right hand side, f of x. So limit x tends to 3. What is the value? Right hand side 5, no? Check it here. 5. So this is 5 because constant does not apply for the limit. Hence LHL is equal to RHL. What is LHL? 4 is not equal to 5. Hence f is not a continuous. At x is equal to 3. Hence except these two values, others are continuous. You can check it one by one. So these are they in one problem. 5 marks they are compulsory asking. So in another different problems A and B are there. In the next problems I will go to find out for the value. So keep in your mind how I am going to take two different values in one function only. That is a very wonderful problems is there. Please try to understand everyone and we will continue the another different problem in the next video. Bye.